Today we're going to talk about rational exponents and radicals. So again, we're talking about two things, rational exponents and then also radicals. So first of all, what does it mean when we see the expression, the phrase rational exponents? When we see the word rational, just think of a fraction. So an exponent written as a fraction. So we're going to study fraction exponents and also radicals. But in order to not get so confused, let's first of all remember one important statement. Right here it says, raising a number to a power is reversed by finding the root of a number. So right here we have an opposite. We have a number raised to a power, and also we have the root of a number. So these are two opposites. For instance, the opposite of addition is subtraction. The opposite of multiplication is division. But now let's look at this. The opposite of squaring a number is finding the square root. So when a number is raised to an exponent, the reverse is finding the root of a number. That's why we have the word radical. A radical is this symbol right here, right there. It looks like an old school division symbol. We have an exponent and also a radical. There's our exponent. That is our radical right there, that shape right there. Okay, let's look at that first example. Right here, we know that this is spoken of as the square root of 25. Now, even though a number is in here, like if we don't see a number right here, we want to assume that a 2 is there. So always keep that in the back of your mind. If we don't see a number right there, we want to assume that it is 2 as being the square root. So we have the square root of 25. Now, when we look at this statement right here, this numerical expression can be written as an equivalent as this right here, which is 25 to the 1/2 power. Now, most of the times we are really not used to seeing something like this, 25 to a 1/2 power, to a fraction power. That doesn't make sense. But now we're going to learn something new right here. So this is also can be thought of to be the square root of 25. We can write it like this. We can write square root of 25 like this. And we also can write the square root of 25 like this with a 1/2 power. So the square root of 25 is 5. The square root, or 25 to the 1/2 power, should I say, is 5. And let's look further. It says evaluate each expression. Now, some of your classes you may have an expression like this, and your teacher may tell you, evaluate that expression. So again, in our previous example, when we have a little 2 there, we write 1/2. But now look at the 3. We have a 3. So instead of putting a 1/2, we're going to put a 1/3. So the cubic root of 125, when we see a 3, that's cubic. It's not square. When we see a 3, that's cubic. The cubic root of 125 can be also written as this. Same numerical expression, just written differently. So we can write this as 125 to the 1/3 power. So the cubic root of 125 is 5. Again, the cubic root of 125 is 5. So right here again, we have a rational exponent written as a fraction. So now, how do we know that it's 5? Because 5 times 5 times 5 is 125. It checks out. Let's look at our next example. Right here we have a 4. So we're not trying to find the square root of 16. We're not trying to find the cubic root of 16 as our previous example. We're trying to find the 4th root of 16. So what number can I multiply 4 times to get 16? So before we get to that step, instead of putting a 1/3, we're going to put a 1/4. So the cubic root of 16, or 16 to the 1/4 power, is 2. How do we know? Because 2 times 2 times 2 times 2 is 16. So again, if we're trying to evaluate our expression, there's our answer. Just as in our previous example, if we're trying to evaluate our expression, there's our final answer. And let's look at our last example. This is spoken of as the cubic root of 27. So what number multiplied 3 times gives me 27? Now again, we write cubic root of 27 like this, but we also can write it as this right here, as a rational exponent. 27 to the 1/3 power. So what is the cubic root of 27? Is 3. How do we know? Because 3 times 3 times 3 is 27. So then